Welcome to the second lecture for week 10. This is lecture 10B. We're going to continue on with lighting considerations. In this section, we're going to discuss or go over incandescent lighting. Incandescent lighting, which is one of the older forms of lighting, at least mechanical lighting, not including candles and other things, makes light by sending electrical current through a highly resistive wire. So much current is put through that wire, it heats the wire up to the point that it incandesces. In other words, gives off light. Now, this wire is usually inside a glass envelope. Now, if you think about it, if I send so much energy through something that it heats up to the point that it glows or incandesces, most of that energy input into the system is converted to heat. Now, this is the beef the federal government has had with incandescents, that the vast majority of energy put into the lamp is given off as heat. Now, incandescent lighting, they have two major types of incandescent lamps. We have your basic incandescent lamp, which has a simple tungsten wire inside a glass envelope. So the two items, real simple. They've been around forever. They come in a bazillion different shapes, forms, wattages, you name it. Simple basic incandescent lamp. Then we have a specialized incandescent lamp, which is called a quartz halogen lamp. They still have a simple tungsten wire, but now they're put in a specialized quartz glass envelope, something that can resist a real high temperature. And the quartz halogen is now filled, or this quartz halogen lamp, the envelope itself, inside this glass envelope, is filled with an halogen gas. But both incandescent lamps and quartz halogen, they're both incandescent type lamps. Now, if we look at the profile of incandescence, of all the lighting types out there, they have the worst efficacy. In other words, lumens per watt. I mean, they can be so bad we can be down in single digits. So the lower the number there, the worse off you are. So the amount of light per the amount of wattage put in, that's a real negative when it comes to incandescent lighting. Another negative, they have the shortest lifespan. Typically about 1,000 hours. If we manipulate some things, we can get that up to maybe 2,000, 2,500 hours, but they do have a short lifespan. Now, on a positive note, they have the cheapest fixture, they have the cheapest lamp, they have the cheapest dimming capability. So I can go out to a home improvement store, buy a cheap plastic fixture for 69 cents, depending on if I still have incandescent lamps that the government hasn't banned, I can get a lamp for like 40 cents. So for around $1, I can have a lamp and a fixture that I simply have to wire up. It also has very inexpensive dimming. Now, here's the kicker. Remember how we went through all the different criteria that's important to lighting before? It wasn't just about energy. Well, incandescent lighting has the best color rendition. Typically, most incandescent lighting starts at about 90 on the color rendition index, goes all the way to perfect color rendition. Quartz halogen lighting, quartz halogen, can achieve a perfect color rendition index of 100. There's no other light source currently that we can achieve a perfect color rendition index other than incandescent, specifically quartz halogen. This type of lighting doesn't impact the environment. Other than, I have some broken glass, I have a little bit of wire. I guess everything impacts the environment, but not to the point where it doesn't contain mercury. It's not considered a hazardous waste. The other thing is it's not impacted by the environment itself. I can go out and put incandescent lamps out in my pole barn and it can be 40 below. I can go out and turn the light on and have light. I can also walk over to my oven, baking my favorite pizza at 550 degrees, and turn on the oven light. So it's not impacted by the environment. They're widely available. I mean, with few exception. They're easily adapted into a building architecture because they come in a wide variety of sizes, shapes, like candelabra. They do add to the air conditioning load, which is another negative, but they also subtract from the heating load. They do not impact power factor because they don't have a ballast. And one other thing that's not on here that should be on here is they're easily modified to get a point source light. In other words, I can focus a light like in a spotlight or a floodlight, which is called point source lighting. Now, potential savings, electrical usage, electrical demand, reduced maintenance. Make sure that a lighting recommendation is not going to adversely impact a business's bottom line. So those are the things that we look at. This ends lecture 10B. When you're ready, you can proceed to lecture 10C.